Hi, my name is Greg and I just received today my Freescale Freedom Board FRDM-KL46Z that I ordered for approximately €11 by Farnell. I will share with you my impression during the unboxing, the first connection of the board, programming of the target, and project debug. The packaging is simple, but the board is very well protected. As you can see, it doesn't move when I press it strongly. It is also compact, which is still nice if you want to start a collection with the 11 Freedom boards currently available. The use of recycled cardboard is still appreciated for the ecology. The reference of the board and its revision are printed on the backside. My version is a B0. Let's discover now the board. The USB cable is not included, but it should not be a problem as this mini USB cable is provided with any high-tech product. Personally, I prefer to save on my development tool price rather than receive an additional cable that will load my drawers. The quick reference card is printed on a glossy paper with high-resolution pictures of the board showing the components and port location and the pinout for the optional headers of the Freedom boards, which are all form factor compatible with the Arduino R3 shields. The board is featuring a Freescale Kinetis-L 256 VLLL4, a 32-bit low-power MCU based on an ARM Cortex-M0 Plus core clocked up to 48 MHz. The KL46 is currently the highest-end derivative of the Kinetis-L family, which means that you can evaluate with this board all the features offered by this MCU family. The device embeds 256K of flash and 32K of RAM, an LCD segment controller which comes with a 4-digit LCD segment display on the board, an USB OTG controller with a dedicated connector, and an hardware capacitive touch controller with a slider electrode. Boards also features two LEDs, a green and a red, two push buttons to generate some interrupts, three sensors, a 3-axis accelerometer and a magnetometer with digital outputs, and an analog light sensors. Board includes an USB debugger, reprogrammable with the OpenSDA applications and compatible with any ID toolchains of the ARM ecosystem. I will show you later how to load a new OpenSDA application to change the debug profile. My computer is running Windows 7. Let's see how the board is detected when I plug it for the first time to the USB port of my laptop. Connect one end of the USB cable to the USB port of the computer and the other end to the OpenSDA USB connector, the bottom one in the screen. Boards comes pre-programmed with the OpenSDA MSD application, a MSD Flash programmer. The device manager will detect two new peripherals and automatically install the right drivers. A new drive, FRDM-KL46Z, is now available in the File Explorer with an USB to serial interface. Save at the same time the COM port allocated to the OpenSDA CDC for future exercises. Some drivers for the OpenSDA CDC serial port are available in the FRDM-KL46Z drive. Double-click on the SDA info.html link to go to the P-Micro dedicated page for the OpenSDA. You will find some OpenSDA firmware like the MSD application or the debug application, and Windows and Linux USB drivers for the P-Micro debugger. So please download and install those drivers before starting your first project debug. Project FRDM-KL46 demo showing different features of the board has been preloaded in the target. Simply press the SW1 button to change the demo. A segment LCD self-test turning on all segments for 3 seconds is automatically launched at startup. Then the KL46 switch to the upcounting demo featuring the LCD controller and a timer, increasing by 1 periodically all digits. The slider demo available while pressing the SW1 button features the capacitive touch controller. The relative position on the touch electrode is displayed on the LCD screen and the red LED blinks accordingly. The last demo, E-Compass, is based on the measurements of the accelerometer and the magnetometer embedded on the Freedom board. It requires first to calibrate the sensors angling the board in multiple directions. Now I can display on the LCD screen direction in degree and LED is blinking faster when pointing to the north. Press again the SW1 button will return to the upcounting demo. To continue your evaluation of the board, I recommend you to go to the Freescale website at the direction www.freescale.com/FRDM-KL46Z. You will find precious materials available in the Downloads section, like the Quick Start package or the sample code package with source code project for different compilers, and to go further, the board schematics and the board user manual. I have already downloaded the Quick Start package on my computer, so I will extract it. I need to approve first the license agreement. The folder includes a Quick Start guide in PDF format with basic instructions, some OpenSDA applications to reprogram the debug interface, I will show you later how, and some precompiled examples. The board comes pre-programmed with the OpenSDA MSD Flash programmer, so you can easily reprogram the KL46 target simply drag and dropping or copy pasting any SRecord file in the FRDM-KL46Z drive, and the demo will start automatically. Let's try it out with the Freedom green LED demo. You don't need to reset the board to program a new SRecord precompiled example. Let's verify it with the red LED demo. We will now debug a project example from the sample code package. Projects for several ID toolchains are available. You need first to reprogram the OpenSDA interface with the proper application. To launch the OpenSDA bootloader mode, simply keep the reset button pressed while plugging the USB cable to the OpenSDA connector, then release it. A new drive bootloader will appear in your file explorer. Open the OpenSDA application folder from the Quick Start package. You will find several SDA application files corresponding to debug tools that you can simply drag and drop in the bootloader drive to change the OpenSDA profile. The MSD is the Flash programmer preloaded in factory. The PE Micro debug app works well with AR Embedded Workbench for ARM and CodeWarrior for MCU toolchains. CMSIS DApp with Kyle MDK ARM, Seeger G-Link available online with Kinetis Design Studio. I have already downloaded an evaluation version of AR Embedded Workbench for ARM, so I will select the PE Micro debug app to debug an AR project. Unplug and replug the USB cable. A new peripheral, Django, PMicro OpenSDA debug driver, is now detected in the device manager. The OpenSDA CDC serial port USB to serial is still available. I will now extract the FRDM-KL46Z sample code package. I need first to approve the license agreement. Inside, you will find two folders. One with bare metal drivers and another one with processor expert drivers only available with Code Warrior project examples. I want to debug an AR project, so I'll go to bare metal, build, IAR, and I choose the green LED project example. I double click on the EWW file to automatically start IAR embedded workbench. Project has already been set up with the right parameters. You can verify it selecting Options. The target device is a Freescale FRDM-KL46Z 256x64. The linker is a 256K of Flash. The debugger is from PMicro. The download for the flash loader is a KL256K of flash, and the PMicro debugger is an OpenSDA USB, so everything is fine. Select Project, Clean. Select Project, Rebuild All. Click on Download and Debug from the toolbar to start the debug session. To start the program in debug mode, click on Go. Press Stop Debugging to finish the debug session and return to the edition mode.